A user taps place order, the spinner hangs, they tap again. Now look at the backend. Without deliberate retry design, that second tap becomes a second charge, a second shipment, a second ledger entry. Safe retries are not luck, they are a system choice. An idempotency key is a client-generated token. Something like idempotency key, ABC 123. It names a logical request, not just a single network call. The client sends it with the first post. The server captures the request and response pair in an idempotency store, keyed by that token. Now a retry arrives carrying the exact same key. The server does not rerun charge logic. It does not decrement inventory twice. It does not create a second-order row. It bends the retry into the idempotency store and returns the cached response immediately. That is the mechanism. Same key, same observable outcome. A double tap produces one charge, one shipment, one ledger entry. But the idempotency key header is only the visible tip. The real correctness lies inside the transaction boundary. The server must check for the key and persist it in the same database transaction that performs the side effects, charging the card, decrementing inventory, creating the order row. Separate those steps and a retry can slip between the check and the persist. Both requests charge the card, both decrement inventory. The guard looks like this: begin a transaction. Select from idempotency keys by key. If a row exists, return the stored response. Otherwise charge, create the order, insert the key with the response, and commit. Stripe and Adyen both use this pattern, returning cached responses on repeated keys. Yet the edge cases matter. How long is the idempotency window? Do you reject a duplicate key while the first request is still in flight? What happens after a partial failure? The answers differ across providers. And remember, idempotency gives you observably once processing, not exactly once message delivery. Choose your TTL carefully. Expire too early and you lose protection. Keep keys forever, and they become storage and privacy debt. Idempotency is not a header bolt-on. The same key must flow through clients, API gateways, databases, queues, and sagas. Protect the front door while the back window is open, and you still get duplicate side effects. Sometimes a saga with compensation, an outbox pattern, or a natural order ID is the cleaner choice. The real takeaway: design the logical request identity through the whole system, not just one endpoint.